Today is Sunday, August 7th, and this is William Michael of the Classical Liberal Arts Academy. While I'm out for a walk on a beautiful August Sunday afternoon, I've had in my mind today anxieties that I hear from parents and students about mathematics in their studies. And while I wouldn't want to spend time on a Sunday talking about mathematics because I like to keep my Sundays free for spiritual thoughts and more sacred reflections while I take a break from work, it's the anxiety that I see in students that distracts them from sacred studies that I think justifies some consideration, even on a Sunday, because it's a spiritual problem. And I'd like to take some time in this talk to students and parents, but primarily to students, about how to study mathematics so that you can succeed and be free from anxiety, because many students approach mathematical studies wrongly, and that's a big reason for why they struggle and then why they're anxious about their math studies. The first question should be, do we have to study math in the first place? Is it necessary for us to study math? Is it necessary for us to memorize all the math facts and do all these math problems? Is it necessary for us to study algebra and geometry? Is this really necessary? And the answer is yes. It is necessary for a couple of different reasons. It is necessary. First of all, the knowledge of mathematical ideas is good for our souls. The knowledge of mathematical ideas is good for our souls. When we're born into this world, our senses dominate our minds. What we see, what we feel, what we taste, what we touch, what we smell. Our senses dominate our minds, and they control our lives, especially when we're young. That's why when a little child is denied a drink of juice, when his senses are turned down, he'll throw a tantrum, throw himself on the floor and start screaming and cry for a half an hour. Having his senses denied causes him to lose control, because his senses are his whole view of reality, all that he understands, the experiences of his senses, pleasure that he receives from his senses. And the purpose of our education is to train us not to be like children, but to fulfill our potential as reasoning human beings made in the image and likeness of God. When we read the New Testament, we read our Lord and the apostles telling us to take no thought for earthly things, but to think of things that are heavenly. Jesus teaches us explicitly not to set our minds on earthly things, but to set our minds on heavenly things. Things that last forever, things that never change, things that we will be able to enjoy for all eternity. Those are the things that we have to learn to appreciate, to desire, and to live for. And when we learn those things, we'll begin to learn that it's good for us to deny the desires of our bodies in order to obtain better things, things that are lasting, things that are permanent, things that bring us joy and happiness, not just the satisfaction of our desires. This is the point of our education, to train ourselves to think like creatures composed of body and souls who are going to live forever, not like babies, not like animals. This is the purpose of education, and the study of mathematics is like a bridge. The study of mathematics helps us, even though we're looking at and counting physical things in mathematics, even though we're counting coins in arithmetic, even though we're measuring shapes in geometry, even though we're listening to sounds in music and looking up at the heavens in astronomy, even though we're still dealing with sensible things in mathematics, we're beginning to learn to think abstract thoughts. We're learning to turn away from those things and contemplate them in our minds. We're learning to think about things that are perfect. So for example, you could draw a circle on the paper, but the circle would not be perfect. But you could walk away from that drawing and think about the definition of a circle, and in your mind you can contemplate on what would be a perfect and true circle. And you may never see such a circle anywhere in the world, but you can understand what a true circle would be through contemplation. The same is true with a straight line or with parallel lines or a triangle. You'll never see an infinite quantity in this world, and yet through contemplation you can imagine what an infinite quantity might be. This is the benefit of mathematical thinking in the Christian life. It's a bridge, as Plato taught 2,400 years ago. Mathematical thinking is a bridge that helps us to move from our senses to our intellect, to begin to become what God created us to be. So mathematical studies are necessary for our spiritual lives, whether we're in school or not. Mathematical studies would be necessary, if we wanted wisdom, that is. But secondly, we live in a modern society where our government actually makes it necessary legally for us to study certain subjects in mathematics. The government actually creates educational laws and regulations that tell us that there are certain subjects we must study. Arithmetic, algebra, geometry, these are subjects that are taught in public schools and we're required to study. Jesus said to us, "Give to Caesar what is Caesar's and give to God what is God's." Give to the temporal ruler what is his due honor, while also giving to God, the eternal ruler, the ruler of all rulers, what is his. And so we're not to disobey government and pretend that being a Christian exempts us from obedience to earthly rulers. That's not true. The state calls for us to study certain mathematical subjects, and it's our duty, therefore, to study them. So both at the political level, living in this world, and at a spiritual level, preparing for eternal life, the study of mathematics is necessary for us. That's the first question, and I hope that once you can settle in that, you can realize that devoting your time and attention to mathematics is good for you. Now, the problem is that in modern schools, they don't have these two things in mind. They usually make the study of mathematics only to concern itself with fulfilling the state requirements. And if they're going to go beyond that at all, they don't go beyond that to seek spiritually beneficial studies in mathematics. They simply try to motivate students by telling them that if they go on and study calculus or this or that, they can get into a better college and make more money. And the motivation is just trying to make more money. Of course, the desire for more money just relates back to desire to please our senses, because that's why people want more money. And if we're trying not to live like babies in 20-year-old bodies, but learning to become wise and spiritual human beings made in the image of God, we're not going to be motivated by the desire for more and more money. We're going to seek higher and better things. And so the ideal math program would be one that satisfies what the state requires of us, but then turns its attention to those mathematical studies which are good for our souls. And in the Classical Liberal Arts Academy, we're the only school program that allows students to do that. We take care of state requirements in mathematics. We offer modern arithmetic courses. We offer algebra courses. We offer modern geometry courses all the way up through high school studies. But we also offer real classical mathematics, classical arithmetic, classical geometry, classical music, classical astronomy. And our desire is to see students complete the state requirements in a simple way and then move on to the study of classical mathematics for spiritual benefits that they offer us. But there's one topic that I'd like to talk about, one topic that I'd like students to really learn and think about as they study mathematics. And that topic is what it means to solve problems. Because ultimately that's what modern mathematics is about. Modern mathematics, modern school mathematics, is supposed to teach students how to solve problems. That's what mathematics is about. How to solve problems using mathematics. And most students don't understand what that means. And it's why they always struggle with mathematics. If you open modern arithmetic book in our program, the books that we choose to teach, or a modern algebra book or a modern geometry book, open any of our modern math textbooks and you'll see that every book begins with definitions and rules. All of our math books begin with pages of definitions and rules. And after these pages and pages of definitions and rules, we then get into exercises. And it's important for students to understand what's going on here. Because what most students do is they read through the definitions and rules, eager to try to get to the exercises. And then, when they get to the exercises, they look up and ask, how do I get the answer? Or what's the answer? And they may get the right answer. A teacher may show them what to do to get the right answer to a problem. And they may get all of their answers marked correct, but they're not learning mathematics. They're not learning how to solve problems, which is really the only thing that matters. The definitions and rules at the beginning of the textbook need to be studied and learned and mastered by memorization. And then when the student moves on to the exercises, those definitions and rules are to be used to solve those problems. And to help you understand this, I'd like to give you an illustration. Let's imagine that we drove into town and visited the garage of an auto mechanic. And we walked into this auto mechanic's garage where he works on cars and repairs cars every day, and we asked the mechanic to give us some advice. Imagine if we asked the mechanic to please give us a list of the tools that we need for our garage at home so that we can repair our own cars. Imagine we asked the mechanic to give us a list of the tools that we need at home in our garage so that we can repair our own cars. Anytime our cars have a problem, we'd like to repair them ourselves. What tools would we need? And imagine that this mechanic was a friendly guy who was happy to help. And he went over into the office in his repair shop and sat down and took out a pen and paper and started making a list. And he made a list, and by the time he was finished, he had a list of 34 tools. And he sat there and thought about it for a little bit. And finally, he got up and came out with that paper, handed us the paper and said, "Here, I've made a list. I'm confident that there are 34 tools that you must have in your garage at home in order to be able to repair your own car. And I've listed those 34 tools here on this sheet of paper." And we took that list of 34 tools and went to the hardware store with that list, and we handed that list to one of the men who works at the hardware store and said, "We would like to buy all of these tools for our garage because we'd like to be able to repair our own cars." And so the worker at the hardware store took the list and went off with a cart and found the tools for us and was loading the cart and came back to us and said, "I'm sorry, but we only have 24 of the tools on this list. We don't have this and that and this and that. We've only got 24 of these tools." And imagine if we said, "That's all right. 24 is better than none." And we then paid for those tools, loaded up the car, drove home, and set up our garage. Filled a toolbox with our 24 tools, and then got ready for our first repair. And one day, as Dad was driving to work, all of a sudden he started to hear a funny sound in the car, and he started to notice that there was smoke coming out from the exhaust. And so he called home and said, "Hey, you know what? We finally got our first chance to work on the car here. Something's wrong with it. It's making a weird noise and there's some smoke coming out of the exhaust pipe. So when I get home this weekend, we'll take a shot at our first repair in the garage." And so you get the car home, you get the car all ready for the weekend, pull it into the garage, get it up on jack stands so you can work on it. And then you run into a problem. You start to identify what the problem might be. You start to, let's say, read through a repair manual, and it gives you steps to troubleshoot the problem. and you look at the toolbox, and you look at the car, and you ask yourself, how are we going to solve this problem? We don't have all the tools. And so what you've got to try to do is figure out what tools you have and what work needs to be done, and whether you can find and fix this problem using what you have, using your tools. This is the work of problem solving. If you don't have all the tools, you're going to have a much harder time, because there are going to be tasks that require a certain tool, and if you don't have that tool, you won't be able to even begin that task unless you can figure out how to use another tool to do the job of that tool. But it's going to be much more difficult to do that. But you've got to think about what you have in the toolbox and how it can be used to solve the problem that the car is having. And then as you read through the repair manual and you learn the names of all the parts of the car and you learn about their functions, you've got to begin thinking, what might be causing this strange noise and this smoke to come out of the exhaust pipe? That's the problem. What's the cause of this problem? And how can we repair it? You've got to start with what you know and use what you know and what you have to figure out a solution to a problem when you don't know the solution. This is the work of problem solving. And here's a very simple definition, I could say, of problem solving, what it means to solve problems. Problem solving is the ability to find what you don't know using what you know. Problem solving is the ability to find what you don't know by using what you know. That's what problem solving is. And this is why when we start studying mathematics, our textbooks begin with definitions and rules. The definitions and rules are like the tools. They're the tools that you're going to use to solve the problems. There are explanations in the chapters. These are like the explanations in the repair manual that tells you about all the different parts of the car and what those parts do. And after you study each lesson, you get to the exercises and you're presented with an exercise. And as a student, you should not ask the question, what do I have to do to get the right answer? Because that's not problem solving. What you should ask is, what do I know, or what tools do I have that I can use to solve this problem? And you have to take your time, go back to the definitions, go back to the rules, read back through the lesson, and ask yourself, what do I know that can help me find the solution to this problem? And when you learn how to do that, when you learn how to use what you know to find what you don't know, you'll be a skilled problem solver. And that's really what you should seek to be in your math studies. And the reason why is because when you get out of school into real life, when you're in business or any kind of work or vocation you have in the future, you're going to face unique problems. You may face problems that no one has ever faced before. In order to solve those problems, you're going to have to know how to work and think like a problem solver. You're going to be limited in the problems that you can solve by what you know. The more you know, the more tools you have in your toolbox. The less you know, the less tools you have. This is why in your studies you should be motivated to study, because every bit of knowledge, every definition, every rule that you learn in your studies is like adding another tool to your toolbox for future use. And when you face a problem, you're to look at your tools and look at the repair manual and ask, what do I know that can help me to solve this problem? And if you learn how to think like that and how to use what you know to find what you don't know, you'll become a problem solver. This is the real goal of studying modern mathematics, to learn to be a problem solver. Now, when most students get to the exercises in their lessons, they don't want to think like problem solvers. They just want to get it done. They just want to grade. They're lazy. They don't care about the real goal of studies. They just want to look like they study. They just want to get it done. They just want a good score on their test. They don't care if they actually learn the lesson that mathematics challenges them to learn. And what good is it to get yourself a high quiz score, or to get a question marked correct, or even to get a high school diploma if you haven't learned the skill that you're going to need to solve problems in real life? And this is how most people are in our society. Most people in our society don't know how to solve problems. They need other people to solve problems for them. They live like children even when they're adults. And they look around waiting for somebody who chooses to live like an adult, who chooses to live like a human being, to solve the problems in their lives. And we can see this behavior when they're students in math classes in school. You have to desire to be a problem solver. You have to learn to think and work like a problem solver. It doesn't matter if you can get the right answer by following the steps that mommy shows you on the chalkboard or that the teacher shows you. It doesn't matter that you can get that one question right, because the question that you have to answer in real life is going to be different. It's not going to look the same. And the easy trick that the teacher showed you is not going to work. The problems in real life are more complicated. They're more difficult. You have to learn how to solve problems when you're young, because when you're older, the problems that actually need to get solved are very complicated. You have to develop this skill. It's like a muscle. You have to strengthen it and become really skilled and agile with the use of it. You have to become a problem solver. A good example of a problem solver in the modern world would be Albert Einstein. Albert Einstein corrected or improved many false ideas of older scientists. Albert Einstein would face a difficult problem, very, very complicated problems, and what he would do is conduct what he called thought experiments. He wouldn't get in a rocket ship and fly up into outer space to study outer space. He wouldn't get into a ship and sail across the ocean to study the ocean. He wouldn't get in some kind of drilling machine and drive down into the earth to study what's inside the earth. Albert Einstein conducted what he called thought experiments. And he would simply sit in his office or in his classroom, and he would think about all the things that he knows and think of how they could be used to answer the questions, to find the answers that he didn't know. And he did this through these thought experiments. And usually when you see pictures of Albert Einstein, you won't see him in a laboratory. You won't see him holding any chemical jars or working on scales in a laboratory or anything like that. You won't see him with safety goggles and a lab coat on. You'll see Albert Einstein in comfortable clothes, standing in front of a blackboard or sitting at his desk with a pen and paper. Many of the problems that Albert Einstein helped to solve, he did by simply thinking about what he knows and how it can be used in a creative way to find what he doesn't know. Albert Einstein is a good example of a problem solver. And what the world needs is for Catholic students to really study and become problem solvers. Not to get the questions right, not to get high scores, not to get high school diplomas, not to just learn the tricks to find the answers to the problems in the textbook. What the world needs is for Catholic students to do the work, to study, to learn the principles, to learn the definitions and the rules of the sciences, and to learn how to use those definitions and rules to solve real-world problems, complicated, unique, new problems in real life, like Albert Einstein did. It's better for you to take a week to learn to solve one problem in your math class and really learn to solve it as a problem solver than to complete 100 exercises and get all the answers right, but not know how to solve problems. Because that ability to get answers right in a textbook is not going to help you in real life. The questions that you have to answer in real life are not going to look like the questions in your textbook. The tricks the teacher showed you are not going to work. You're not going to be able to ask for help. You're just going to have what you know. And again, what you know is going to depend on how much you've studied, how hard you've worked to study and learn. You're just going to have what you know and the ability to solve problems with what you know. And you're either going to be a problem solver or you're going to be a person who has to wait for other people to solve their problems. And in mathematics, you should work to learn to become a problem solver. So when you face an exercise in your math book, you shouldn't just look for the quick 3-step method to find the right answer. You should ask, how does what I know, how do the definitions and rules that I've learned provide the means by which I can solve this problem? It's good for you to think of different ways to solve problems, because you'll learn how to use what you know in creative ways to solve problems. And when you face new problems, problems that no one has ever seen before, you'll know how to use what you know to start looking for the solution to that problem. Back in the 1700s, to share another story about another great mathematician, Isaac Newton was working to bring together the study of the natural world and the study of mathematics. He wanted to understand the world, the natural world, mathematically. But the problem is that when you begin to look at the natural world, you find that it's impossible to do calculations because everything is constantly changing. It's not like an arithmetic problem. You can't just add 3 apples and 5 apples make 8 apples. What if the number of apples is constantly changing? And so the mathematicians who wanted to solve problems in the study of the natural world realized that they were going to have to find ways to calculate and solve problems when things were constantly changing. For example, if I wanted to figure out if I shot an arrow and I wanted to shoot an arrow 1,000 yards, how hard would I need to pull the string back on the bow? How fast would I need to shoot the arrow? What angle should I shoot the arrow at to make it travel 1,000 yards? And I could sit and start calculating the angle and the speed the arrow has to move at and calculate exactly what I would need to do to make that arrow travel 1,000 yards. But then, when we got out into the field with our arrows, all of a sudden the wind would change. And we'd say, what do we do now? Anytime we shoot arrows outdoors, the wind is going to change. So now we have to learn not only how to calculate how to shoot an arrow, but we have to learn how to calculate and change these calculations as conditions change. And so the science and the mathematical calculations get more and more complex. And this is the challenge that real scientists face. Well, those early physicists in the 1700s, what they realized was that the math rules and the math definitions and the math textbooks that exist weren't even complicated enough to answer these questions, and that before they could even start to seek the answer to these questions, they had to invent the math rules. They had to, discover the math rules. They had to discover math rules and define terms and discover different concepts that would allow them to study the natural world. And that's where the study that we call calculus came from. These scientists had to first develop the science of calculus in mathematics before they could study the natural world in a mathematical way. They had to basically get more tools before they could start solving the problems. And you see, that's an example of problem solving. The problem they had was the knowledge of mathematics at the time wasn't enough to solve the problems. So in order to solve the problems, they had to use what they knew to figure out what they didn't know. And then after they figured out what they didn't know, they could then use that to figure out what they originally wanted to study. And that's how mathematics and problem solving allows us to solve more and more problems in the future. And when you study mathematics, that's what you should be seeking to learn. You should be seeking to learn how to use what you know to solve problems and find answers that you don't know. That's why it's important for you to master the definitions and the rules. And anytime you see a problem or anytime you're asked a question, to think, what do I know that can help me to find what I don't know? Learning to think like that, learning to take your time in mathematical studies is what will allow you to become a problem solver. And that's what it means to be a real master of mathematics. Not to get through the lessons, not to get all the questions right, not to get the highest scores on all the tests. That will all come easy later on. The goal of studying mathematics is to learn how to solve problems, to learn how to reason through problems by using what you know to discover what you don't know. And that's what I want to challenge you in the study of mathematics. Master the definitions and the rules in your mathematics lessons, and when you face problems or exercises in the courses, don't look for shortcuts and tricks to get the answers right. Don't go Google a solution to the problem. Go back to your definitions, go back to your rules, and ask yourself, how can what I know help me to solve this problem and find the answer that I don't know? That's what it means to study mathematics. I hope that's helpful. God bless.